Hi there, guys. This is 15F. We're about to look at the T distribution rather than the Z distribution. Now, in 15E, we did the test for the mean of a normal distribution. And in one of the questions, let's just click across. One of the questions here, in example 5, it said, from past experience, it is known that the standard deviation of the bags filled by the machine is 20 grams. Well, that's unusual information to be given. Normally, when you're testing to check what the mean is, to check if the mean is the same as what traditionally it has been, you don't know what the standard deviation is as well. And so you're going to need to make an estimate of the population standard deviation from the sample. So this is where we use the t-test. Okay, so if we click forward a little bit here, skip with me. We click forward, here's the t-test. We're going to need to make an unbiased estimator of the population variance. We did that in chapter 13. But importantly, I'm just going to flick on to at the end, just before the exercise, there's 3 important reflect questions. It says, when should you use the t-test instead of the z-test? Well, we use it when we have to make an estimate for the standard deviation. So the z-test is often where we start in statistics, but the more often used test later on is this adaptation of the z-test, which is the t-test, where we are now making an unbiased estimate for the population standard deviation based on the sample standard deviation. And we know that that's likely to be slightly larger than the sample standard deviation. In order to do this, you will need to know your degrees of freedom, or at least you should know about these things. In the test, I think you might be able to just give n on the calculator, but either way, the degrees of freedom for these tests are just one less than the number of observations which you have. So it's simply n minus 1 here. If the question asks you for that, and sometimes it's a 1-mark question, then all you're going to do is take, like in this case, sample size is 14. That's in part A. Sample size of 14. You just take 1 away to get your degrees of freedom. Okay, and how do you find the unbiased estimator for the variance if you've got the sample variance? Well, you can just get it from your calculator. It's the one which is noted as SX on the TI Inspire, or SN-1 compared to sigma n for your standard deviation. So this is going to be SX on your calculator, but we'll see that in a bit. But you should know how to use the formula as well. Let's go back to it. The formula is here. Now, remember, we did this in chapter 13. Let's just copy and paste this one. Just take this. Now, remember, the variances are connected. And here we go. We've got this formula to show us this. So we've got SN. So that's our sample standard deviation. So sample standard deviation squared times by n over n minus 1, which, if you think that n is, for example, 10, then 10 over 9 is going to be slightly over 1. So that's going to give us a slightly larger answer for Sn minus 1 squared. So this is our unbiased estimator for sigma squared, for our variance of the population. Okay, if you've just got the standard deviation, if you're told the standard deviation, then if you square root both sides here, then the standard deviation estimate, so the unbiased estimator for the population standard deviation instead would require us to square root this. Then we'd also get the square root of the other side. So we get n over n minus 1 all square rooted, and then Sn, the sample standard deviation there as well. So you've got the 2 formulas there. From my point of view, I would try and remember this formula here, that the variances are connected by this very simple multiplier, n over n minus 1. You want it to get slightly larger when you're estimating the population standard deviation. Okay, so that's what we're going to need to use. Now, in terms of the question, Actually, the answer is the working out for this is easier than the working out for the ztest. Here, you don't need to work out critical values. So you just need to work out p-values, and essentially, you can ask your calculator to do the t-test. And you can do it in two ways. You can either do it based on statistics, which is part A, or you can do it based on, or you can do it based on data. So in part B, you've got the data there, and we can do it through sheets. So we'll look at both of those methods of doing that. Just briefly, there's a little bit of a note on the t distribution as compared to the z distribution. The z distribution is very, very similar. So they're both bell-shaped curves. It's just that some of them are closer in and some of them are flattened out a bit. And that's to do with the fact that the variance is larger for the t distribution. So here, for example, they say, if you have a look at something with 1 degree of freedom, so that will be 2 bits of information, in fact, a sample of 2, that's the green one here. You can see that the green graph is sort of flattened out. It's got a flatter peak, but it's higher up at both of the edges there. And then if you look at the normal distribution here, normal distribution is in blue, I think. So the normal distribution is closer in. So they're really closely connected, these things. It's just that the t distribution is a kind of flattened out version. Okay, on your calculator, you don't have the inverse normal distribution, which is why we can't work out critical regions in this case, or at least not on the TI and Inspire. Okay, so let's take example 7 then. So let's steal this thing here. Okay, so this one says, in order to test the hypothesis, so they're giving you H0 and H1 in this case, that the mean is 8.2, and H1 is that the mean is less than 8.2, so we're doing a one-tailed test in this case. A sample of 14 is taken, and the mean of the sample is found to be 8.15. The standard deviation of the sample is 0.07. And then it says test at the 5% significance level whether the sample is from the population given or one with a smaller mean. Okay, so, sample of 14 is taken. Oh, it really should say that this is taken from a normal distribution, because a sample of 14 is too small to use the central limit theorem in this case. I think that's a mistake in the question. And let's just show you that, actually. That in the book, I should say up here somewhere or other. What does it say? Here we go, in the hint, I think. In the hint, it says, the use of the t distribution, the t-test, still requires either the background population to have a normal distribution or the sample size to be large enough for the central limit theorem to apply. In other words, if this information is coming from, say, for example, a background distribution which is binomial or Poisson, for example, then you'd need a sample size of at least 30 in order for you to say that X bar is distributed using the central limit theorem via a normal distribution. Otherwise, it needs to say. Now, it doesn't actually say in that question, and I think it should. No, it doesn't say, but it should do. Okay, so let's have a little look through then. So to start off with, we're going to need to make an estimate for our population standard deviation. So again, in order to do that, we need to use the formula that connects it. So we've got Sn minus 1 squared is equal to n over n minus 1 Sn squared. Now, of course, this is equal to Sn. So you just need to substitute in this case. So we've got 0.07 squared, and then we have here 14 over 13. Sorry. Okay, it's getting a bit messy, isn't it? Take that further down. So we say that that's 14 over 13, and that this is 0.07 squared, and that's going to give the answer for Sn minus 1 squared. So we'll need to then square root this answer afterwards. Alternatively, you can just do square root of 14 over 13 multiplied by 0.07, which is exactly what they've done here. Okay, so they've got this. That's the sample standard deviation. So we're now testing against that normal distribution. We're testing X bar, okay, because we've got a sample mean here. So we're testing X bar against the null hypothesis is that it follows this distribution, normal distribution, with 8.2, comma, and then this is our 0.0726 is our standard deviation. So we're obviously going to need to square that. And of course, you should keep as many decimal places as possible in order to get an accurate answer for this as well. So don't truncate this on your page. On your page, write down somewhere or other what the actual answer is to as many decimal places as possible. Okay, so at this point, we can then go and use our calculator, and we can go to Scratchpad. So calculate, menu, and statistics 7 on the TI Inspire, and we can do stats tests, and then we can go to the t-test, which is the second of our tests on the TI Inspire. And we've got an option here to use data or statistics. So I'm going to use statistics in this case. And I'm going to go OK. And so now I'm confronted with a table, which I need to fill in. And so the table asks me to put in mu0. So mu0 in this case is the 8.2. It asks me to put in the sample mean, which is 8.15. It wants Sx. Now, Sx is another way of saying Sn minus 1. So it's another way of doing this thing here. It's noted on your calculator, or at least on the TN Expire, it's noted as Sx as well. And you'll notice that when you work out some distribution statistics by working through the spreadsheets as well. Okay, so you'll need to put in the answer, this answer here. Now, let's see how far off I am by using that answer. So 0.02726. And n in this case, they're not asking for the degrees of freedom, which is 13, but n is 14. And then the alternative hypothesis is, well, we're interested in mu being less than 8.2, so we're interested in the alternative hypothesis of mu being less than mu0. And so then I'm going to go OK on this one. And I've got some results, and I'm going to show you exactly what you'd be getting as well on your calculator when you put this stuff in. So when you put all of this in, you should get these as your answers. Now, I've put in actually this answer. I shouldn't have done that. In fact, the calculator suggests that you can do your working out on Scratchpad and save it, so store your answer as A. So go Control, Variable, Store, and type A, and obviously enter. So this is your calculation for your unbiased estimate for the standard deviation. So they've put in A when it comes to putting in the statistics. So again, follow the thing I did on Scratchpad menu, statistics, stat test, t-test. You've got to put in this information here. Now they put in A instead, so let's see how different their answers are to mine. So let's just zoom in once more. Okay, so I'm getting, I put in all the same information apart from I put in the rounded off answer here. So the p-value is the thing that you're interested in. We want the p-value to be less than 5% in order to reject the null hypothesis. And in this case, you can see it's 0.011528. Now for me, it's 0.01149566. So in fact, mine rounds off to 3 significant figures to the same answer as theirs, but to 4 significant figures, it's a different answer. So I could lose an accuracy mark there for not using the correct amount of for using too few significant figures by truncating my answer for my standard deviation, in fact. Okay, but in fact, I'm getting the same answer for P here to 3 significant figures. And there we go. We can see that this is less than 5%. Therefore, reject H0 and accept that mu is equal to, is less than 8.2. So accept the alternative hypothesis, reject H0. Okay, so we also want to do the spreadsheets version of this as well. So spreadsheets version is perhaps even simpler. So again, let's have a look at this one. It says the sample below is thought to have come from a normal population. So they should have said that for the first part as well, with a mean of 34.5. Tests this belief at the 5% significance level. Now, what we could do is go to spreadsheets and put in this information and then work out one variable statistics, and you'll get a list of statistics, and included in that list of statistics, it will say SX SN minus 1, which is your unbiased estimate for the standard deviation of the population based on the sample standard deviation. Okay, you can do that, and then you can use, and you can also get the mean, of course, from that information, and then you can do exactly the same method as part A. So you can then, in Scratchpad, feed these values, these statistics, via a statistics method, a stats method for the t-test, into exactly the same method, exactly the same process as part A, and we can find the p-value again. However, this one is potentially easier on the calculator by just going and putting the information straight into the sheets. So let's do this live at the same time. So I'm going to go to home again. I'm going to go to add another lists and spreadsheet to a new document. And I'm going to put in my information. I've got, what information have I got there? I've got 34.3. It's going to take a little while. 30.2. I'm putting this in column A. 29.7. 34.4. 33.6. 35.7. 34. 33.9, 35.1, and 34.5. Okay, now instead of doing one variable statistics, I'm going to go straight to a t-test. So I'm going to go menu, and I'm going to go to statistics. I'm going to go to stats tests. So it's pretty straightforward. T-test, and in this case, I'm going to use a data method. So I'm going to go OK on that. Now, mu in the null hypothesis is 34.5. Okay, it's telling us that the mean for the population is expected to be 34.5. And again, we're testing here not to say, this is one of the two-tailed tests. We're not saying necessarily that mu is smaller than this, the mu zero, if you like. We're just testing to see if we have a different mean in this case. We don't have an opinion on whether it should be smaller or greater. In fact, we haven't done any calculations from this data yet, so we wouldn't know whether to test whether it's smaller or greater than the H0 or mu zero. Okay, so the list, so I'm at the t-test on the calculator. I've put in mu zero as 34.5. And my list is in column A, so I'm not renaming column A, I'm just putting A with square brackets in. Frequency is 1, each of these things turn up once. And the alternative hypothesis is okay, I don't need to change that, it's just a two-tailed test. And it asks, where should I put the results? I'm putting it in column C, so that's fine. I don't want to draw anything, so I'm going to press OK. Now I've got all of my information in that one. So let's have a look here. Let's see what turns up here as well. So you put in your information in here, data method via t-test through the menus. And they've called this list X. So they've renamed the list at the top. I didn't bother doing that. I just went and called that A with the square brackets. And then frequency list 1. They've gone results column B. My default was C, doesn't really matter. and then the p-test in this case is 0.161171, and I'm getting the same answer here as well. You'll also notice that you have further down that list, you can't see it here, but further down the list, they're giving you SX or SN-1, which is your unbiased estimate for the population standard deviation as well. In fact, that's all you need to do for that one. So here we can see that the p-value is greater than 16%. It's greater than 5%, in fact. So 16 odd percent. So therefore, we don't have sufficient evidence to reject H0. So we are not accepting H1 in this case. Okay, right, I think that's that. Let's have a look what else is in the book. I think that's done. Okay, importantly, you don't need to work out critical values in this case. There's no inverse t-test, or at least not on your calculator. Okay, so 14F is next, and after that we're going on to confidence intervals.